Today we're going to further explore finding the greatest common factor using a method called prime factorization. So our goal is to find the greatest common factor or greatest common divisor of two or more numbers by using prime factorization. In previous videos, I've shown you how to find the greatest common factor by listing the numbers. Now we're going to do it another way, and for some of you, this way may be more helpful. First, I want us to review some very important key vocabulary. So we remember that a common factor is a whole number that is a factor of two or more non-zero whole numbers. The greatest common factor is basically the largest of those common factors, or it's also known as the greatest common divisor. Prime factorization is the method of expressing whole numbers as a product of only prime numbers. And if you already have these vocabulary words in previous notes, they should be well organized and you should be able to refer back to them, and you do not have to copy them down again. Of course, if they're missing in your previous notes, you're going to want to copy them down again. So let's look at some examples of how we can find the greatest common factor using prime factorization. Let's look at our first example. Find the greatest common factor of the numbers using prime factorization. So our numbers that we're going to look at are 28 and 45. So let's start by using a factor tree to give us the prime factorization of 28. And of course, there's different ways to model the prime factorization. I'm going to start with 4 times 7. There, of course, is another way. You could have just said 2 times 14 and split it up further, but I'm just going to start with 4 times 7. Once you get there, circle your prime numbers, and you can highlight it too if you like. For some people, that's more helpful. Now, 4 is composite, so we need to break that up into our prime numbers, which is 2 times 2. So that's our prime factorization of 28. Now let's look at the number 45. Well, it ends in a 5, so you know that it's divisible by 5. And 5 times 9 is 45. 5 is a prime number, so I'm going to circle that one. And then 9 is composite. It can be broken down into two prime numbers of 3 times 3. So now I'm going to circle my prime numbers. Now when you find the greatest common factor, keyword common, you look at the numbers that you have in common. Now I started with this example for a reason. Keyword here is common, because there's another way of finding least common multiple using prime factorization, and students get them confused sometimes, or they interchange the rules. So I want to start with greatest common factor, and we need a common factor. So let's look at common factors of 45 and 28. Well, I can look and I see I have 2 times 2 times 7 is the prime factorization of 28, or 2 squared times 7. And then 45, I have 3 times 3 times 5, or 3 squared, 3 to the second power, times 5. I notice that I have no common factors here, so there's nothing in common. So some students will say, oh, well, the greatest common factor is 0. No. Remember, 1 is neither prime nor composite. So if you see no common factors, that means that the greatest common factor is 1. Because, of course, 1 times 28 is 28. 1 times 45 is 45. And we used prime factorization in order to figure out that the greatest common factor of these two numbers is 1. So again, to repeat that, if you have nothing in common, the greatest common factor is 1. This is a little bit more obvious when you're listing factors. However, finding the greatest common factor using prime factorization will help save you time when you're dealing with very large numbers. Let's look at another example using prime factorization. Find the greatest common factor of the numbers using prime factorization of 180 and 126. So let's start with 180. Of course, 180 ends in a 0, so I can break that up between 10 times 18. And I notice that neither of these are prime numbers, so I'm not going to circle 10 or 18. I need to further break them down. So 10 can be broken down into 2 times 5, and I know that 2 and 5 are prime. And 18 can be broken down to 2 times 9. Now 2 is prime, but 9 is composite, so that one I can further break down into 3 times 3, both of which are prime. So now let's look at 126. So I can first break this down. I notice that 6 is even, and again, there's more than one way to break these numbers down, but I'm trying to use examples that make the most sense to you. So I notice that 126 is even, so that can be broken down into 2 times 63. 2 is prime, so I'm going to circle that. 63 can be further broken down to 3, because I know it's divisible by 3 because 6 plus 3 is 9, and that's divisible by 3. You might also notice that it adds up to 9, so it is also divisible by 9, which is probably how I would have originally broken it down, but I'm going to keep it 3 times 21. Again, 3 is prime, so I'll circle that. And I have 21, which can be broken down to 3 times 7. So now I have common factors and I have prime factorization. So first I'm going to list the prime factorization of 180. So I have 180, which is 2 times 2 times 3 times 3 times 5. And I have 126, and I'm actually going to not put this in exponential form, just so that I can point out the common factors. So I have 2 times 3 times 3 times 7. Remember, we can use those dots to represent multiplication as well. So then I need to look for common factors. So I've copied this slide again so that I could show you printed out nice and neat what each prime factorization looks like. And again, I did that without exponents. So looking at 180 and 126, we have the prime factorizations listed, and so now I just look for common factors. So I have a 2 in both cases. I have another 2 on the top, but I don't have it on the bottom, so I'm not going to circle. I have 3s, and I have a second set of 3s. This is, of course, why I don't put it in exponential form, so that you don't have to worry about keeping track as much. So because from the factor trees I can see that I have a 2, a 3, and a 3 in common, the greatest common factor is 2 times 3 times 3, or 2 times 3 squared. 3 times 3 is 9, 2 times 9. The GCF is 18. So my greatest common factor of 180 and 126 is 18. Now, you might notice that this is much easier to use. It's much easier to use this method instead of listing factors when you have large numbers, because it'll really save you time. If you listed all the factors of 180 and 126, and then you would find that 18 is the greatest common factor, that would probably take you longer than using prime factorization. It will definitely save you more time when you have very large numbers. So let's move on to another example. Let's find the greatest common factor of 84 and 216 using prime factorization. So I'm going to start with 84, which can be broken up into 7 times 12. I'm going to circle my prime number, and then I know that 12 is composite, so it can be broken down further into 2 times 6. Again, circle your prime number, 2. And 6 can be broken down into 2 times 3, both of which are prime. Now let's do our prime factorization of 216. There's different ways you can break this down, but you might notice that 216 is even, so you can definitely divide it by 2. Also, you might notice that the last 2 digits are 16, so that means it's divisible by 4 as well. And the last 3 digits are 216 because 100 is divisible by 4, 200 is divisible by 8, 216 is also divisible by 8. So I'm going to break it down by 8 times 27. Neither of these numbers are prime, so I have to break both of them down further. 8 can be broken down into 2 times 4. 2 is prime. And 27, 2 plus 7 is 9, so I can break that down into 3 times 9. 3 is prime. Then I have 4, which can be broken down into 2 times 2, both prime numbers. And 9, which can be broken down into 3 times 3, again, both prime numbers. So now I have my prime factorization, and I've circled all of my numbers. So now I'm going to list the numbers on top and bottom, and I'll do it nice and neat for you. So now you see that I have it printed nice and neat, so it's easier for you to notice the common factors. So we have 2's, we have a second set of 2's, and we have one set of 3's. So my common factors are 2 times 2 times 3, or 2 squared times 3, which means my greatest common factor is 2 times 2 is 4, 4 times 3 is 12. So my greatest common factor between 84 and 216 is 12. Now I want you to take a minute to review your notes. Go ahead and pause the video and check your notes to make sure you have all the information you need. Now I want you to check your notes with mine. Make sure you have all the important information. Again, your notes can look slightly different, but all the key bits of information should be there. If you're missing any details, make sure you're entering them now. Go ahead and pause your video and compare it to my own notes. Let's move on to finding the greatest common factor of numbers using prime factorization when we have more than 2 numbers. So if we have 49, 54, 102, we have to make 3 factor trees. So let's start with 49. 49 is a composite number, and it can be broken down into 7 times 7. 7 and 7 are both prime, so I have my prime factorization. Moving on to 54. 54, 5 plus 4 is 9, so I know that 9 times 6 is 54. Neither are prime, so I can break down 9 into 3 times 3. Those are prime. And 6 can be broken into 2 times 3. Both prime. Now we have 102. 102 is even, so I know I can break it down into 2 times 51. Some of you might think 51 is a prime number. It is not, it's composite. And really look at the number. 5 plus 1 is 6, so you know it's divisible by 3. And 3 times 17 is 51. Again, making sure you're circling all the prime numbers. So now we have our prime factorization. So I'm going to list the factors of 49 first. We have 7 times 7. 54, we have 2 times 3 times 3 times 3. And 102, we have 2 times 3 times 17. Looking at all three numbers, I notice that 54 and 102 have some numbers in common. However, I need to have it in common with all three numbers. And looking here, we can see that we don't have any. And remember from earlier in the lesson, if I have no common factors, that means that my greatest common factor, no common factors using prime factorization, means my greatest common factor is 1. So the greatest common factor of 49, 54, and 102 is 1. Now let's look at one final example of finding the greatest common factor using prime factorization of three numbers. So we have 120, 144, and 192. So let's start with 120. Ends in a 0, so I have 12 times 10. Both are composite. We have 2 times 6. 2 is prime. And 10 can be broken down into 2 times 5. Both prime. 6 can be further broken down into 2 times 6. 2 times 3. Both of which are prime. Now let's look at 144. Well, hopefully you know that 12 times 12 is 144. 12 can be broken down into, again, 2 times 6. Also can be broken down into 4 times 3. And I'm just showing you it this way to show you the different ways of breaking down the numbers and still getting the correct answer. So I can break 6 into 2 times 3, 4 into 2 times 2. And now I have all my prime numbers for 144. And last, 192. 192 ends in a 2, so I know it's even, but I also noticed that 92 is divisible by 4. So I'm going to break it down into 4 times 48. 4 can be broken down into 2 times 2. And 48 can be broken down into 4 times 12, which both can be broken down even more. 4 can be broken down into 2 times 2. And 12 can be factored into 2 times 6. Again, circling my prime numbers as I go along. And finally, 6 is broken down into 2 times 3. So now I have all three numbers factored. So now I'm going to actually type them up and list them very neatly because we have to compare factors of three numbers. So now I have these typed up nice and neat for you to see. So I have 120, 144, and 192 all factored for you here. So now I'm going to look for common factors again between all three numbers. So I have a set of 2's, another set of 2's, a third set of 2's, and lastly I have one set of 3. So my common factors is 2 to the third power, or 2 times 2 times 2, times 3. Which means that my greatest common factor is 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. So my greatest common factor using prime factorization between 120, 144, and 192 gives me 24. I hope that helped you. Go ahead and take a minute to review your notes. Now I would like you to take a minute to look at my notes that I've sampled for you. Make sure that your notes are not missing any information Go ahead and pause the video.
Just a reminder, we'll have a faculty meeting in the library in about 7 minutes at 1:30. Thank you.
Sorry about that interruption. We will go ahead and review your notes. Go ahead and pause the video. Great job taking notes. Now it's time for you to, of course, fill out any questions, concepts, keys, and summarize your notes. You've done a great job. Now it's time to take a break.